I showed making this lock ring in the last video. I added 2 holes for the spanner, and there's another hole through here that has a very small brass slug in it with a point on the end. I'm going to go out on a limb and say this is the smallest piece I've made on my lathe. And then a threaded hole here with a very, very short number 10 set screw with a point on it. And so that set screw is going to push on that little brass slug and lock the threads in place. That was an idea that I got from Stefan Gottswinter's video on rebuilding his rotary table. And so that just locks it in place. I've got a piece of bronze that I'm going to use to make an eccentric bushing for the worm to live in. And I could do this in the lathe and just offset it in the 4-jaw chuck. I'm just going to put it in the collet block here and do it in the mill instead, and that way I can make sure that it's nice and straight. I'm making my fair share of mistakes as I go here, and this bronze bushing was one of them. Somehow I got off on where that hole was drilled. I also didn't have long enough drill bits and reamers to go through it in one shot, so it just turned into a mess. So I pressed another piece of bronze in to fill that up, kind of soldered it up a little bit. Nothing really bears on this, so that doesn't matter too much. And then went back and drilled a hole in the right place. Since this was the only piece of stock that I bought for this project, I wanted to salvage it if I could, and that should work okay. Getting this hole drilled for this eccentric bushing has been a challenge because it needs to be 4.7 inches deep, which is less than the clearance between this and the bottom of the collet chuck. It wouldn't have been too bad if I could set this up on an angle plate, but I don't have one. And this collet chuck is really, really stuck in here. It does not want to come out. I've tried a lot. It's pretty much stuck in there, so I just work around it. But with moving it in and out to change drill bits, I managed to drill this out to 15/16. I have a reground end mill that's just under 1 inch, which is enough for me to get this reamer down in here to get it started. It's doing the job. Get it done. Cleaned up another piece of rusty cast iron to make a piece to hold the eccentric in. Pretty good fit. I made a little oversight, which is I need 2 holes to hold it in, but I also need to put a set screw in this to lock the eccentric in place. I can't put it in the top because it would hit this shaft. So what I'm going to do is actually go back and just drill 2 more on diagonal. I'm going to go ahead and pop the hole in this for the set screw. I'm going to drill it the whole way down with a number 7 drill bit and then thread 1/4 part of the way down. It doesn't need to go the whole way down because I'm going to put a little brass slug in there to keep from marring up the bronze eccentric. We'll get this squared up here and then come in with the transfer punch, mark 1, drill and tap it, screw it in, and then mark the other one with the transfer punch and finish it up. The grain in this piece tells me that this is almost certainly wrought iron, but we'll get it cleaned up and see what we can get out of this piece. So wrought iron has fibrous slag inclusions in it, which give it this sort of grain structure. I hit this with the sandblaster after I went over it with the needle scaler. I was going to knurl a piece of this, but I kind of like this texture, and I might just try to skim cut it a little bit to smooth it out and just leave that texture. Getting this thing trued up is a bit of a challenge, but basically what I did was just kind of brought a tool in until it just barely touched, and just kind of try to work so that where it does touch the high spots, it touches more or less evenly around the thing. I was getting a lot of chatter with the carbide tool, so I swapped over to a nice sharp high-speed steel tool to take the last couple passes here. So I want to get the collar to rotate the eccentric out of this, and the dial. From the far end, I'm going to do part of the hand wheel and the part that the dial is actually going to ride on. But this surface finish is pretty poor. And I'm just going to try to clean that up with some emery cloth here. That's more like it. There are still some traces of those slag inclusions in here, but I don't think I'm ever going to get rid of those. I'm drilling this hole with the center right on the edge of the other hole. So using a drill bit really wouldn't work, so I'm just going to plunge it with a series of end mills. And so now you can see how that eccentric moves the worm in and out to engage and disengage it. There we go. I've got this back in the lathe, and I've got the dial on there with just a set screw, and I'm just going to face this off so that they're the same length, and then actually go back and probably take another 1/1000th off of this, just so when it's all cranked together, it's not binding on the dial, it's actually pushing on the inside of the hand wheel, the shank of the hand wheel. This was one of those cases where as soon as you drill the hole, you know you screwed up and it's not going to work, but you try anyway. This shank is just too big, so this hole was too close to the edge. So I'm just going to remake this thing and do a smaller shank on that, get a little bit more meat on the outside of that. And there it is. I did this one with a 1/4 inch shank on it instead of 3/8, so there's a lot more room there, and it actually ended up being sort of a slip fit, so I kind of glued it in there. This is obviously frustrating, but it gave me the chance to do one that I think actually ended up coming out better. Real happy with that. Man, that's satisfying. What's not satisfying is this hole. That's way bigger than that should be. So I'm just going to make a plug out of whatever that is. Press it in there. That might have pressed in there a little easier than it should have, but we'll just hit it with a big end mill and see if it moves. I know that the parallelism is off on this a little bit, so I'm just going to go ahead and fly cut the whole thing. This is just a 1/1000th indicator, but for the purposes of seeing if it's parallel enough to start scraping, I think that's pretty good. You didn't really want to watch me do this again, did you? So looking at this thing in place, I'm just going to knock this in half, and that should give me a pretty good size. I decided to drill and tap the tabletop rather than cut T-slots in it because it's a little bit less than 3/4 of an inch thick. Obviously there will be issues with chips falling in here and keeping them clean, but I still think this is a better way to go than trying to do little mini T-slots in here. Now I know what you're thinking, there's no way to indicate this in to get the spindle centered up on it, but I have a plan for that too. So by default, this circle is going to be centered on the rotary table. So I've got that indicated in as well as I can. Spent a little extra time doing this since every time I use this from now on, it's going to be based off this. And I'm confident that the spindle is now directly over the center of the rotary table. So that was a great plan that failed miserably. As you can see, the hole is not actually centered on here. So we're going to go to plan B. One of the last things I need to do is do some graduations on this dial. I was going to do 100 graduations on it, so it would be 5 degrees with each degree split into 20 pieces. But it turns out I don't have a good way to do 100 graduations. I've been doing the indexing on the lathe, and I don't have a 100-tooth gear, and I don't have a 50-tooth gear either. So what I think I'm going to do, at least for now, is do 60 graduations. Rather than working in decimal degrees, I'll work in minutes. So that'll give me 5 minutes per division. So I've got a carriage stop set up here so I can just crank it over till it hits, back up, and index it. And every 12th one, which is the full degree, I'm just going to crank the cross slide in and maybe do every 6th one, which is half a degree. The stop did slip a little bit, so the lines aren't exactly all the same, but I'm not going to lose sleep over that. Now I'm just going to do a light skim cut to knock some of these burrs off and clean it up with some emery. And for the final touch, get some numbers stamped on here. And I believe this is the last of it. I don't think I can end this video without doing a little demonstration of this in action. I knew going into this project that it was going to be a challenge for me, and it was. I certainly made my fair share of mistakes, but I feel like I worked through them and worked around them well enough. And in the end, I'm pretty happy with how this turned out. Thanks for watching.